In this video, we're going to go through a problem a little bit more in depth. So here we have the probability distribution for the number of successful cures out of 5 patients going through chemotherapy. These are skin cancer patients, and we're looking to find the expected value. We're looking to find the standard deviation. We're then going to graph the probability distribution, and we're going to figure out the interval where we're 2 standard deviations away from the mean. We're going to decide by looking at the graph whether we should use Chebychev's rule or the empirical rule to approximate the probability that X is going to be within 2 standard deviations. And then we're going to use part C to answer part D, which is, would you expect to observe fewer than 2 successful cures out of 5? So let's start. I'm just going to move my data down a little bit so that we can work with it. So the first thing I'm going to do is find mu. And so to do that, I'm going to take my X values and multiply them by the probability that they happen. So that's going to be this number times this number. And then we're going to sum up all of those values, and we get 3.5. So this is my expected value is mu. So what does this mean? Because it does say interpret the results. So what this is saying is that on average, the number of successful cures out of 5 people treated with chemotherapy is 3.5. But we know that 3.5 out of 5 is the same thing as 7 out of 10. So what this is really saying is that 70% of patients that undergo this treatment are cured. So when they say that certain medical treatments have a 70% success rate, this is what they're doing. They're calculating these kinds of factors. They do trials with 5 patients, and they record what happened, and those over the long run become our theoretical probabilities, and then we use those to calculate the expected value. How often would we expect somebody to be cured? All right, so now we want to find the standard deviation. So we're going to find the distance of all of our X values from the mean. And then we are going to square those values. And then we are going to multiply by the probability. So I'm going to take this value and multiply it by our probability. So we want to find the sum of all of these, and that's going to be our variance. I'm just going to move these down a little bit. So we're going to find the variance, and we're going to find the standard deviation. So we're going to sum up all of our squared deviations times the probability. That's our variance. And then we're going to square root the variance to find the standard deviation. And that's A and B. So we answered A here. This is A, along with all of this stuff is also A. And then this is the answer right here to B. So now we want to graph P of X. So we're going to take these 2 columns. We're going to create a scatter plot. We're going to change it into a column graph. And we're going to take a look at what we have here. So if we get rid of the gap width, this is our graph. And you can see, if we just look here, this looks approximately normal. Okay, this is a bit skewed, but it is approximately normal. We could imagine that if we kept going, if we had 6 or 7 patients, we would sort of see this taper off on the other side. And so our mean is right here, right between 3 and 4. Okay. So what we want to find is we want to figure out like how far, what's our interval for the 2 standard deviations from the mean. So we need a lower bound and an upper bound. So we're going to do mu minus a standard deviation plus or minus a standard deviation. And then we're going to do, actually we want 2 standard deviations. We're going to find the lower bound for that. We're going to find the upper bound for that. And then we're going to figure out how many values, what's the frequency of the values that are actually inside those boundaries. Okay, so my lower bound is going to be my mean minus 2 times my standard deviation, which is here. And so there's my lower bound. My upper bound is going to be identical, except I'm adding 2 standard deviations. So I'm just going to change that to a plus. And so there's my lower bound and my upper bound. And now I need to figure out how many values are in there. So according to Chebychev, Chebychev's rule, we have we're 2 standard deviations away. So there's at least 75% of our data is there. According to the empirical rule, we're 2 standard deviations away. And so that would be 95% of our data. So I want to know, okay, well, what does this actually come out to be? And so I'm going to count ifs. And I'm going to count ifs all of the values. Actually, I'm just going to look because this is group data, so I can't use a countif. So we're just going to count them up. So we know that 1.45 is less than 2. So I really just need to sum up the values in these categories right here. So 2 standard deviations away starts at 2 because 1.4 is between 1 and 2. So I can start at 2 and go all the way up to 5 because the upper bound is 5.547. And so I just need to sum up these probabilities. And it's telling me that there's a 96.9% chance that we're going to fall within this interval. So this is really much closer to the empirical rule than it is Chebychev's. And so I would say, yeah, I think this is looking like normally distributed data. And so knowing that 96.9% of the time, 97% of the time, our values are going to include 2 to 5. So we're going to be within 2 standard deviations. This question is, would you expect to observe fewer than 2 successful cures out of 5? Well, only 3% of the time I would expect to see that. And so, no, only 3% of the time would this be expected. And so you can see that we are we are experiencing the combination of using probability. So what's the probability that you would observe fewer than 2 successful cures? Okay, it's less than 3. Well, it's a little bit more than 3, actually. It's 3.1. But only 3% of the time, and we used all of the stuff that we learned back in Unit 1 to answer that probability question. All right, I will see you in the next video.